أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله وبركاته. Thanks to Allah subhanahu wa ta'ala for all his blessings and bounties that he has bestowed upon us. فَبِأَيِّ آلَاءِ رَبِّكُمَا تُكَذِّبَانِ. Allah subhanahu wa ta'ala has been very, very kind, very, very merciful by sending Anbiya alayhi salam to guide humanity so that each and every mankind could be successful not only in this life but the life hereafter. All the Anbiya alayhi salam since Adam alayhi salam till the last messenger Muhammad sallallahu alayhi wa sallam, they came to existence to work on the hearts of the people so that it could be inculcated into the hearts of the people that the sole Khaliq, the Malik of this whole universe is Allah subhanahu wa ta'ala. Nothing can happen without the will and wish of Allah subhanahu wa ta'ala. It comes in a hadith more or less meaning, there is a piece of meat in the body, if it is corrected, the whole body is corrected. And if it is corrupted, the whole body is corrupted. Make sure this piece of meat is your heart, is your heart, is your heart. So we need to think and ponder why Allah subhanahu wa ta'ala has given each one of us in existence, the real purpose, the objective of our life. So inshallah, learning, talking and propagating it will be very, very beneficial for all of us. So if you remember from the last lecture, we are still talking about the foundation. Foundation, the one which is essential to look into the ultimate objective of this particular topic, we need to talk about initial value problems. So how the initial value problems are going to be handled, we need to transform into the algebraic, those complicated physical phenomena which cannot be simplified analytically. Or they are going to be very, very expensive computationally. So we transform them into the corresponding algebraic equations. From the algebraic equation, we look into the solution. Once we find the solution of those algebraic equation or problem, so the inverse of Laplace will take back to the solution of the given physical phenomenon. That's what is the overview. Start off with the initial value problem. We transform by utilizing Laplace transformation. The process of finding Laplace transform is known as Laplace transformation. And then from the solution of algebraic, we have to utilize inverse of that. So if you look into the last lecture, we have gone through with the unit step function. Take a step of 1 unit, whatever the scale is there. Here is the definition. It will be 0 for all sort of values of t less than a, and it will be 1 because you are talking about unit step. So it takes a jump of that much. So this is all. You can move on. Eventually, if you combine together, it will turn out to be piecewise function with pieces being combined together. If you further go back and remember the first shifting theorem, quite a few valuable things we have discussed. Over the last couple of weeks, the first shifting theorem is basically utilized when we have a product of exponential function together with f of t Yep. So exponential function is multiple of f of t. F of t could be any expression over there. So the Laplace of this combination is going to be f bar of s minus a. So this is known as first shifting theorem for Laplace transforms. Now we move on to the second shifting theorem for Laplace transform. We have just gone through in the last lecture, ended up with the definition of unit step function. So this definition is going to be utilized. The Laplace of unit step function u a of t is equal to e raised to power minus a s upon s. So it states that if we know the Laplace transform of f of t as f bar of s, a symbolic representation, then the Laplace transformation of f of t minus a u a of t. So the involvement of unit step function. So remember, they should be compatible. A over here and a for f of t minus a. So it will turn out to be e raised to power minus that a, being the subscript of u, and t minus a. It will take into the expression e raised to power minus a as a bar of s. What is a bar of s? Is the corresponding Laplace to f of t. Laplace of f of t is a bar of s. So we omit the proof, otherwise you can look into the literature for the proof. So we do utilize this one, but occasionally. The second shifting theorem, it will only be applicable if you do have the combination of the function together with the unit step function. We move on to more useful, more valuable things to be discussed when we talk about initial value problems. So initial value problems are basically mathematical model together with initial conditions generally. And those mathematical formulation will involve derivatives definitely. So this is all. We have to have Laplace transforms of those derivatives involved in those differential equations, being the mathematical formulation of the physical phenomena behind the scene. So it has more than one versions. If f of t is continuous on t on this interval for all sort of non-negative values greater than or equal to 0 and is of exponential order, f of t is continuous over that interval and is of exponential order. Exponential order means for very large t approaches to infinity, this combination is going to approach to 0. It will converge to 0. So with this condition, continuous and of exponential order, on top of that, the first derivative is piecewise